for section 5.8 coordinate proofs, we're just doing part of the coordinate proofs. We're not going to do full proofs. We're just going to kind of explain and say what we would do if we were to do it. So the first thing is, what is a coordinate proof? A coordinate proof is where you actually have things on like an X and Y axis, like a graph paper, and you use the numbers from the picture to help you with the proof. So it's a good idea usually if you're going to take a picture, like here are your X and Y axes. If you were to put a triangle on your coordinate system, it might be a good idea to put it on the x-axis going through or starting from 0, 0. So if you can somehow position it so that a corner is at 0, 0, that's a good idea. If you can keep it in quadrant 1, so it's all the numbers are positive, that's a good idea. Keeping it on the x or the y-axis, the x-axis or the y-axis is a good idea, or both if you can. So kind of placing your triangle in a convenient way is a good idea. So, example 1. Place the figure in the coordinate plane in a convenient way and assign coordinates to each vertex. So, first one, I'm going to draw an x and y axis. Here's the x, here's the y. We need an obtuse angle with height of 3 and base of 2. So my first thought is just to make it a standard like 2 long and 3 high, maybe like this sort of triangle. Base is 2, height is 3. The issue is it does say obtuse, and none of these angles are going to be obtuse. So in order to make it obtuse also, we're going to need to pull this top maybe out to here. Make our triangle look like this. This angle right here is obtuse, and now the base is 2, the height is 3, and we go through 0, 0, and we're along the x-axis. It's not the only option, it is just an option. The second one here, a rectangle with length of 2w. Here's your x-axis, your y-axis. Now here it's a little tricky because we don't necessarily know how, we only know one dimension, which is the length of 2w, and we don't necessarily know how big w is. So I'm just going to go out maybe to here, and then up, and I'm going to say that this point right here, that height is 2w. And I don't know what the width is, but in this particular case, it doesn't tell us what the width is, just the length. All right, example 2. Write a plan for the proof. You do not need to prove it. So I'm not even going to write it down. We're just going to talk about it. You can listen because you're not going to see a lot of coordinate proofs in this class, just a couple. So write the plan for the proof. You do not need to prove it. We see the coordinate of vertices O of triangle OPR and of triangle QRP. OPR and QRP. And we need to prove, in theory, that these two triangles are congruent. Well, we just talked about all those shortcuts, side, 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 angle, angle, side, and HL. Because we know the coordinates, it would be fairly easy. It would be a lot of work, but it would be doable to actually show that this side and this side were congruent, and this side and this side were congruent, and the middle is congruent to itself by reflexive. So let's just count the bottom. 1, 2, 3, 4, 5, 6, 7. The bottom is 7 long. The top, 1, 2, 3, 4, 5, 6, 7, is 7 long. So the top and the bottom have the same length because we counted. The middle is congruent to itself by reflexive. All we really need to do is show that OP and RQ are the same lengths. Now to do that, on the back of this paper are some hints. You would need to use the distance formula to find the length. So you could use the distance formula on OP and use the distance formula on RQ. As long as you get the same number, these are congruent by side, side, side. Now as you do this, you're not going to be doing a flow proof. You're basically just going to write it down and say the math. And somewhere in here you would say side, 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 so they're congruent. Let's think one more. Let's talk about the plan. Example 3 will be the last one we do. So, the coordinates of triangle OAB and triangle CDB are given. How would you prove that B is the midpoint of AD and OC? Well, think. To prove something is the midpoint, we would need to prove that, say, AB and DB were the same length. So it looks like B is the point 3, 3. You would need to use the distance formula for A and B and the distance formula for D and B and show me that they have the same distances. You would do the same thing for OB and CB. You would need to show me that this length and this length were the same using the distance formula at the end. Now, just a friendly reminder, the midpoint, the distance, and the slope formula are all provided on the final exam formula sheet.